Right. Now broadcasting. And then in about 30 seconds, the attendees will be able to start joining, and so it'll start populating. So. All right, good morning, everybody. Thanks for starting to join. We'll get started in just a minute or so.
O'clock is awfully early.
I'm finding that in our work from home world, it's earlier than it used to be. So.
We might be dragging them out of bed for this one. Most everyone is been operating remotely, right?
Right.
I'll let you make the call, Aaron.
All right, why don't we give it one more minute, and then go ahead and get started. I see some more people starting to join in the attendees list. All right, Chris, why don't we go ahead and get started?
Okay. Good morning, everyone. I realize 8 o'clock comes real early when you're used to sleeping in. So thanks for joining. Thanks for having me. What an exciting time to be an engineer or even an engineering student at General Motors. Well, I guess I should introduce myself. I'm Chris Kinser, the director of the Global Autonomous Driving Center. Hopefully you saw my bio before joining, but exciting time to be an engineer. I'm on the board we call an invention review board at General Motors, and we ask all of our engineers to submit ideas to be patented. And we hold this meeting once a month, and there's 20 to 40 new inventions each month. And I'm only one of the 5 or 6 invention review boards. Mine's focused on automated driving, control systems, electrification, and marrying 2 disciplines, taking 2 ideas, a combination of sensors and actuators, and artificial intelligence are driving a lot of new invention. So I'm excited for you, and I think you're in the right spot here in the Auto Drive Challenge to stretch yourself and use some of these great skills that you're learning in class. So let's get started on what is the Global Autonomous Driving Center. Well, my business resides at the Milford Proving Ground. That's in the northwest suburbs of Detroit. Someone really wise, almost 100 years ago, chose to purchase this big plot of land out in the middle of nowhere, and it was truly the middle of nowhere back then. Suburbs have grown out now, and there's a lot of people that live around here, but back then it was the middle of nowhere. And it's given us just a brilliant tool to really do total vehicle development. There's few OEMs that really have such a facility. There's a lot of little startups that have to borrow time from others or pick a public place to test, but we have everything we need right here in our backyard. I report to Wayne McConnell. We affectionately call him the mayor of Milford. He has over 1,000 engineers that are focused on total vehicle development. What Wayne likes to say is we take the ordinary and make it extraordinary. So really an interpretation of that is the vehicle's total is worth more than the sum of its parts. We have a lot of release engineers, or we call them design release engineers, that are developing components with our suppliers. And each of those components have a function, but when you put them together, they don't all necessarily do what you expect them to do. And the team at Milford puts the polish on those parts. When they come together, we adjust the thickness of the dash mat, we tune the bushing, we change countless calibrations in the engine and the transmission, the electric machine control, the camera and the radar, all to put the polish and make the sum worth more than its parts. So when does the Global Autonomous Driving Center participate in vehicle development? Here's a really simplified timeline of our product development. Someone has to write down the requirements. What's the vehicle going to be? How is it going to delight the customer? Next comes an architecture. You can think of what does the chassis look like, the track width and the wheelbase, and how much mass can it handle, types of powertrains it'll have. And then all of that drives into what we call component design, where we ultimately need a tire, we need a wheel, we need an electronic control unit, we need headlamps, etc. So the DREs take those requirements, water them down to components, and then finally we get to build prototype vehicles. Prototype vehicles then we can engineer, like I just mentioned, at the proving ground. And then the final tuning and polish happens before we launch. And that's really where the Global Autonomous Driving Center sits. We're right here near the end. We're the crazy folks that drive around these cars with black and white stickers all over them. We call them camouflage or disguises for the vehicles. So when you see those running around, you're sure to know someone from the proving ground is driving them. What I like to say is we are the last line of defense on a path to delight our customer. Just a few days ago, my team brought me an issue. There's this little steering wheel icon that we use for our Super Cruise feature. And the steering wheel icon appears in the instrument panel cluster, right in front of the customer steering wheel there, on the radio center stack screen, in the center to the right for the customer, and then in the heads-up display reflected on the windshield. And they noticed that steering wheel icon was different in all three implementations. So the requirements were set, and the release engineer said, we need a steering wheel icon for Super Cruise, but each design release engineer working with the supplier implemented it in a different way. It wasn't until we put it all together that the engineer noticed, my team noticed, and immediately we can escalate that item and get it fixed and give a better experience for our customer. Just a minor example, there's thousands of those that happen every day. And every chief engineer will tell you, when my prototype car arrived at Milford, I was afraid it would never be ready, but it gets there, and it's impressive what we accomplish by tuning all the parameters to be ready for the customer. So what is it we do? Well, I'm called the Autonomous Driving Center, so yeah, we work on autonomous vehicles. We do work with Cruise AV in San Francisco, and welcome to take any questions about that. But what I wanted to highlight was it's really available to each and every one of you every day, and the products that we have, we deliver to our customers every day. So one example of a feature we work on in the Autonomous Driving Center is automatic park assist. Such a cool feature, really a wow feature, a car that can parallel park itself. Does it need to happen faster? Do we want it to do it without you helping it search for a spot? Sure. But does it work? Heck yeah. It's really cool. And I'd love to show off this feature. A lane keep assist. Such a simple idea. We use the front camera. We use artificial intelligence or machine learning, and we train the microprocessor to find the lane markings, to find the lane lines, left and right lane line of any lane you're in. And then we predict whether or not the vehicle is going to cross over those lane lines. Why? The customer was distracted. They're leaning on their steering wheel. They're reaching to get a drink. And as they start to leave the lane, not only is there a warning, but we add steering torque to the steering wheel to push the vehicle back. We try to hold the lane line. Sometimes we can push you back toward lane center. But what a great opportunity to save lives and prevent people from leaving the road. Adaptive cruise control. Conventional cruise control has been around for probably 40 years now, just maintaining speed. But now we go further. We use both the camera and the radar to identify which target, we say, is in path. And then we control the speed now. Instead of just setting to a constant speed, we control the speed to keep the set distance, or what we call headway, with the car in front of us. Again, relieving some of the takeover necessary, adjusting of speed that you might have on a long trip on the interstate. What I personally use adaptive cruise control for, besides the convenience, is I allow it to be that safety net for me. Because let's face it, we all get distracted. And when distracted, if the car in front of me chooses to decelerate and I miss the moment they start decelerating, it could even be a heavy deceleration. Control system's never asleep. It takes over. It starts decelerating, and that brings me back to the driving experience so that I can take over if necessary. And then Super Cruise, the last one I want to highlight. We launched this in the model year 2018 Cadillac CT6. So proud of what my team accomplished for this feature. If you haven't heard of it, I'll describe it briefly as true hands-free driving on the highway. So the vehicle holds the lane center and manages the speed, much like adaptive cruise control, to give a total driving, or should I say driverless experience. Now, it's not full autonomy. We want the driver to be part of the experience, watching the road, because anything can happen. My favorite example is the refrigerator that falls out of the back of the pickup truck in front of you. The customer needs to be prepared for that, to take over and avoid. But in nominal situations, the car drives itself all speeds, all the way down to zero, even in a traffic jam. And what surprised us as we developed the Super Cruise feature, it was a delightful surprise. We thought we were, just providing the customer convenience. But what we didn't know until we took a few long trips, part of the development process is getting in our prototype vehicles and going for long trips to find mountains and curves and hills. We go to Pittsburgh and West Virginia and Ohio, the desert, Colorado, you name it. But on these trips, after long rides, we realized at the end of our route, when Super Cruise is active, we were less fatigued. So next time you're driving the vehicle, you go out today, tomorrow or the weekend, pay attention to how engaged you have to be in the driving experience to be successful. Constantly moderating your speed with the accelerator pedal, constantly touching the steering wheel to hold lane, checking each mirror. The Super Cruise feature takes a lot of that workload away from you. And we're excited about that comfort and the lack of fatigue that it gives our customer. This is just 4 of more than 20 features we work on at the Global Autonomous Driving Center, including side blind zone alert, 360 camera view, collision imminent braking. The list goes on and on, all designed to protect our customer. So why do we do it? Well, it's simple. We save lives, but I love this study that came out of the University of Michigan. And I'll just highlight one of the statistics on the screen here, and that is the 82% reduction. So we have a feature called rear automatic braking. We call that rear virtual bumper in engineering talk. We have a rear vision camera. This pops up every time you shift to reverse to make sure there's no one or nothings behind the vehicle. And rear cross traffic alert, again, using artificial intelligence and machine learning, it's identifying cars and pedestrians that may be crossing behind the vehicle while you reverse. But when those 3 features are present on a General Motors product together, we reduce the risk of a bump or a crash by 82%. So a population of millions of vehicles, some with and without the feature. University of Michigan did a deep dive into all of the police reports of collisions that happen, and they were able to find that our features reduce crashes, collisions, accidents, and injuries by the percentage you see on the screen. And I'm really proud of what that's bringing for our customers every day. No doubt aligned with GM's vision. I believe you heard Cindy Bay in her keynote yesterday talk about our vision for 0 crashes, 0 emissions, and 0 congestion. No doubt both the active safety features that we're putting in cars today and the full autonomous program that we work on in San Francisco are guaranteed to eliminate crash. How do I know that? Because we won't launch autonomous driving until it's safer than you, safer than the human. And once it is, then we'll deploy it. So since you're all starting on a journey, not only working in school, but eventually we'll have jobs in industry, I just wanted to give you a minute to describe my journey so you can see what does it take to become an executive at General Motors or other OEMs for that matter. So this is just one path. There's many ways to get here, but this is my career timeline. I started earning my bachelor's in electrical engineering from Kettering University. Old enough that it actually wasn't called Kettering University back then. I'll let you Google that. My first assignment at GM was working on our EV1, General Motors' first electric vehicle in 1997. Because there was no internal combustion engine, I developed a all-electric brake system. That put me in what we call the chassis control realm. And over a 7-year period, I grew to be what is really an expert in chassis systems, embedded controls. And I developed a system of electronic stability control, which combined all three steering, braking, and suspension systems to keep a vehicle from spinning out. That project earned me GM's highest honor as an engineer, the Boss Kettering Award. Then there was an uncertain time around 2008 when GM was entering bankruptcy. And this is when I pivoted my career and I joined our electrification team to work on the Chevrolet Volt. After the Chevrolet Volt, I worked on our second EV called the Chevrolet Spark EV, and then our third EV you see on the screen here, the popular Volt. My mission here was designing all new features, plug-in charging, mountain mode, battery thermal conditioning. I put together a template of what they need to do for the customer to support the mission and handed them off to software engineers that implemented them. I established myself a leader in complex control systems. This earned me a trip to Shanghai, China. And I learned a little Mandarin. 你是我的朋友. That's my probably really bad accent saying, you're my friend. But I was able to take my wife and 2 daughters on an international trip to Shanghai. It was an exciting time. Not only did we get to see the world, but I got to work with our partners on helping them develop electrification and deploying a plug-in hybrid system on a Buick. Over this 17-year span, again, I met people along the way. I established relationships, and I earned respect for what I was capable of. And I got the phone call that asked me if I'd like to return to the U.S. and run the Global Autonomous Driving Center. And I've been doing this now for 3 years. I've grown my team from about 80 engineers to 160. And we're continuing to grow as this technology grows and needs more and more of us to be successful. Finally, I just want to share with you guys some advice, recommendations for launching a career in automated driving. I drop a line of code on the screen, a line of code you've probably all seen from a basic programming class. And it's intentional to say, if you're a mechanical engineer, take the time to learn software and controls, and vice versa. If you're a computer scientist, spend the time to learn what is a chassis, what is a tire, what is a suspension. And the best way to do this, in my opinion, is make it a hobby. Race cars on the weekend, or in my case, I develop a smart home. I have thousands of lines of code I've written to control the lights and open the garage door and turn on the security system in my house. The hobby that keeps me close to what software looks like as I manage hundreds of engineers in my day job. And then second, be patient. No young engineer wants to hear this. We're all ready to conquer the world. But there's something about a career that takes time because we all need wisdom. And wisdom comes from experience, and experience takes time. But I use this the second piece of advice with dual meaning. Not only do you need to be patient as your career grows, but automated driving is going to take patience. We've been at this a few years now. We've solved a lot of problems, and we've made a ton of progress. I'm really excited to say I watched our Bolt EV that's been turned into an autonomous vehicle drive itself around the proving ground with no one inside. We can do it, we can build a scene, and we can drive. But there's a myriad of problems that are really hard to solve. Let me describe one really quick. When you drive a vehicle, you're in charge of all the passengers. And you look around the vehicle and you say, buckle up, it's time to go. When the car is driving itself, We need the control system. We need the artificial intelligence. We need cameras to decide, is everyone buckled up? And if you can just think through the problem, let's say a customer chooses not to buckle up, okay? Maybe we chime and ask them to buckle up. Let's say they attach the buckle behind how they're sitting. Is it our responsibility now to make sure they're buckled before the car drives? Okay, let's say the person's even more clever and they buckle the buckle behind them, and now they wear a t-shirt. They've screened that they've printed a stripe on that looks like a seatbelt. Do we now still have the responsibility to ask that customer to buckle? So it's just a really small example of all the problems we have to solve as cars drive themselves. But we're solving them every day, and we're excited about it, and we're going to get there. But when we get there, the car will be safe. It'll be safer than you, and it'll be an awesome experience. So that's what I had to share this morning. Thanks for having me. And if you have any questions, hopefully maybe they're in the IM chat there, Aaron, or something where you can ask.
Yeah, so if anybody has any questions, feel free to type them in the chat box, and then happy to answer any.
You can see in this final picture here, this is a rendering of our Volt EV that's purely autonomous. As you can see, there's no longer a steering wheel, no longer brakes. The freedoms that this is going to provide to interiors is a really exciting opportunity for us. But again, another something for you to ponder. How do I process this in a plant? We're used to operators jumping in, moving the vehicle off the end of line to DVT and out of DVT and into the shipping process. How would we do that without steering wheels? A lot of tough problems to solve, and we're doing exactly that. Any questions coming in?
No, I'm not seeing any questions, Chris. Oh, hey, we got one. Here we go. What kind of skill set is needed to work in the automation division of General Motors?
I have all types. Some of my most successful engineers, again, are multidisciplined. I love mechanical engineers with software experience. I love computer scientists that understand the automobile. I love electrical engineers because they can think abstractly. It's really about a set of experiences that you bring, and what you're doing today at AutoDrive is an excellent resume building opportunity that I look for with my engineers. I do want to then ask the most popular question for you guys, and that's the question about, you've all seen the psychological study about there's an option for the autonomous vehicle to either, let's see, steer to the left and hit 4 puppy dogs, or steer to the right and hit a criminal that's actively running from the cops. I got to tell you, that's an invalid question. It's a fun psychological study, but the autonomous vehicle of the future will not have to make that choice because there's one thing missing from that, and that is stopping. Not only will we be able to stop, but we'll have redundant ways to stop. So there's really no way the vehicle will have to make that choice. In fact, if we thought there was a situation where that choice had to be made, we would just slow down. The top speed of the AV that we're working on in San Francisco is 32 miles an hour because the compute and the sensor set won't let us go any faster yet. And as that modernizes and we're going faster, again, we'll always have the ability to avoid, stop, or abort if we ever had to make a decision like that. Any more questions, Aaron?
No, I think that was it. So thanks, everybody. Please, if you're interested in anything either Chris was talking about or Cindy yesterday, or any future opportunities at General Motors, or just interested in what we're doing at General Motors, feel free to stop by our sponsor booth. There will be folks in there at any of the times that it's open, and so feel free to pop in and we can talk about anything you'd like to. So Thank you all for your time. Chris, thank you for your time too.
You bet. Thanks for joining. Have a good day.